Next, let's talk about how we can connect networks on the Google Cloud. Before we move any further, let's disambiguate the term network. Here, network might refer to a Google VPC or it might refer to an on-prem network. Let's first talk about the simpler case of connecting Google Cloud networks, that is, of connecting two VPCs. Here we have two options, shared VPCs and VPC peering. Before we describe them, let's first understand why we might want to connect two VPCs. Remember that a VPC is always in a single project. So one VPC exists in one project and only resources on that project can use that particular VPC. But what if we have multiple projects and we would like resources in these multiple projects to be on the same network? For instance, what if they are all part of the same larger product? That's where these two features of shared VPCs and VPC peering come in handy. Before we go into further detail, remember that shared VPCs need to be in the same organization. VPC peering will work even if the VPCs are in different organizations. That said, let's now talk in more detail about each of them. Let's start with the shared VPC. This is a feature which allows multiple projects within the same organization to share a VPC network. This setup can centralize the management and security administration of the network, and it allows for consistent configuration and better resource utilization across projects. By using a shared VPC, the different projects can securely communicate with each other while also benefiting from the unified network infra. To summarize, we use shared VPC across projects on the Google Cloud. In this particular feature, we have one VPC which spans multiple projects. Shared VPC will only work with projects that are in the same organization. And importantly, there are two types of projects. We've got to designate one host project. This is the project which owns the VPC network and the associated resources. In addition, there are service projects. These are projects that use the VPC network resources from the host projects. The shared VPC feature allows us to build some interesting architectures. Here is an example of shared VPC where we have got one host project that's towards the center right of the screen, and then we have two service projects A and B over on the left. Notice that within each of these service projects, we have corresponding VM instances. So we have instance A inside service project A and instance B inside service project B. What's important is that these two instances are on the shared VPC network. And that's why the internal IP addresses for those instances A and B have been specified within the host project. Finally, note that both of these IP addresses are internal. So here we have two different instances in two different projects, which are still communicating with each other using internal IP addresses, and that is because of the shared VPC. Let's talk about the other way to connect two Google networks together, and that's VPC peering. VPC peering is going to work even if the two projects happen to be in different organizations. This is a great way to set up a network with high performance and low latency, and we avoid the need for additional gateways, virtual private networks, or external IP addresses. Here is a schematic block diagram where we show VPC peering in action. We have two projects, projects 1 and 2. Within these, we have the corresponding networks called Network A and Network B. Notice that there are peering routes in both directions. Both networks need to accept the peering connection for this feature to work. Now, VMs on these networks can communicate using internal IPs and over Google's network infrastructure. Let's hit some of the main points about this VPC peering feature. Like shared VPCs, VPC peering is used to connect two or more VPCs connected across different projects. But importantly, this time the projects need not be in the same organization. Resources on different VPC networks will be able to communicate using internal IP addresses. So traffic between instances on these peered VPCs will not hit the public internet. This increases security and reduces latency. It's also important to note that the resources on the network will use Google's infrastructure to communicate. So again, we are avoiding having to send traffic over the public internet while communicating between two Google networks which happen to be in different projects, even if those projects belong to different Google Cloud organizations. Next, let's move to the enterprise connectivity options on the Google Cloud. Enterprise connectivity here implies that we might be connecting VPC networks with each other or with other networks which might be on-prem or on other cloud platforms. We have two options here, Cloud VPN and Cloud Interconnect. Cloud VPN is easier to set up and is cheaper, but gives you lower bandwidth. Cloud Interconnect is more expensive and more complicated to set up, but it offers higher bandwidth connections and it avoids the public internet. With that high level distinction in mind, let's now talk about each in more detail. The VPN in Cloud VPN has the usual full form. It stands for Virtual Private Network. So Cloud VPN is a service that allows us to create a secure and encrypted connection over a less secure network such as the public internet. This way, users can send and receive data as if their devices were directly connected to a private network. We set up a Cloud VPN tunnel between an on-prem network or another cloud provider's network to our Google Cloud VPC network. This tunnel would be through an IPsec VPN connection. The traffic would be encrypted as it travels over the public internet. In terms of the key features of how Cloud VPN works, remember that we need two VPN gateways, one at the cloud network and one on the on-prem network. This is how the secure connection can be established. Traffic gets encrypted at the VPN gateway on the way out. It then hits the public internet and then comes back to the other end of the tunnel after traversing the tunnel where it has to be decrypted. This encryption and decryption process makes sure that while the data is on the public internet, data privacy and security are still maintained. It's worth noting though that for this encryption and decryption to work correctly, key interchange needs to happen. This key exchange is itself a fairly complex technical process. Cloud VPN makes use of something known as IKE version 2, that's the Internet Key Exchange Protocol version 2, and it also makes use of Diffie-Hellman for key exchange in order to establish a shared secret key without directly revealing it. Cloud VPN is fine for relatively low bandwidth connections, and it's also relatively easier and more lightweight to set up. The other enterprise connectivity option, which is more heavyweight, is Cloud Interconnect. This in effect establishes a high speed and low latency link between our on-prem network and our Google VPC, or this could also be a different cloud network and the Google VPC. In either case, this happens through dedicated physical connections. As you might imagine, this is a lot more expensive, but it also leads to far greater bandwidth and lower latency. Within Cloud Interconnect, there are three possible options. The first is for a direct physical interconnection. This is through a fiber optic cable directly from our on-prem data center to the Google Cloud infrastructure. This option is ideal for apps that require real-time data processing or very large data transfers. This is known as dedicated interconnect. Another option is called partner interconnect. Here, the connectivity occurs through a service provider. That service provider will be drawn from a list of providers who already have established physical connections to Google's cloud infra. This is not quite as heavyweight as dedicated interconnect. Also, it simplifies the setup process because the service provider takes the onus of managing the physical infrastructure and the connectivity. A third option, which is suitable if you have resources on a different cloud provider, is called cross-cloud interconnect. Here, the interconnection happens through a co-location facility where a dedicated physical link will be set up between the Google network and the network of the other cloud provider, which might be AWS or Azure. Potentially, other cloud providers could be connected as well. So to summarize, across all of the different enterprise connectivity options on the Google Cloud, it's always going to be possible to set up dedicated and secure connections between an on-premise network and the Google Cloud resources.